thank you so much for that introduction. So part of these issues have really already been discussed this morning, and as many of you know, I have done a lot of things, papers, discussions with Jonas, but I'll try not to repeat what he said and just add to this what's been said in the morning. And I think probably I'll challenge part of what you've been saying, so that was good, and you just can protest. I've built this talk a little bit on a paper that I wrote with Dee Asplund and Carl Hamilton. I just want to say that. Right, so can I shift slide? Or does somebody else? Yeah, right. So as Jonas saying, so reasons for taxing road transport, and as he said, it's marginal cost pricing and also cost coverage, the financing principle, and in the US, obviously, it's a lot of financing principle where they earmark the revenues from the road user to the road transport sector, but also the EU has sort of a mix of these marginal cost pricing, but also the financing principle. But as you've been saying, many of you in the morning, so there seems to be fiscal reasons as well, and that's why when we look in the future and see more electrical vehicles, many people are afraid of the revenue losses and what will happen then. So this is clearly also an important point in most economies. So we started out with this study trying to see what will happen in the future when we have most electric vehicles. That's where we started. What will happen to the marginal costs? What will happen to cost coverage? And also what will happen to fiscal? Is there a good is it a reason to tax road, even electric vehicles, for fiscal reasons? So next slide, please. So basically, and these are also much of the issues that we've been discussing this morning. So, but we set out what are actually the marginal external cost of transport. Can we know this more concrete, maybe than when you discussed in this morning? Scanning the literature, it's a lot of average values, but as you know, there is huge variation across lengths, across times of day, and obviously where you are in the world. But can we say anything more about that? Can we say also with this information how far we get in covering the cost for the road transport sector with the revenues from this optimal Pigovian tax? And in this perspective, obviously, as you were already discussing, and when you're choosing tax instruments, you have to think about how to collect this. Do we go for a kilometer tax? For urban tolls, we also have large revenues from parking fees in many countries, including Sweden. So how far do we get with those? And also these time-based taxes. So that would be vignettes for heavy traffic, but also ownership taxes, which is also cheap, which are also cheap to collect. And then finally say something about the case for fiscal taxes, which is it has to do with the questions above as well, because it depends on the sizes of these, the relative magnitudes. So next slide, please. Thank you. So as I said, we started to scan the literature. What are the marginal external cost of congestion? And now both for light vehicles and heavy roads. And we were very disappointed. There's lots of average values, which doesn't say anything, basically. Knowing this, since I have also evaluated a lot of congestion pricing systems the Swedish ones and others too, you know that there's huge variation. So it's not so relevant with these average values and doesn't tell you anything about what the total revenues would be in a city or a county or a country. And we are also noticed, and even in the discussion here, we tend to focus a lot on cities, and even like huge cities like Paris, London, but most road transport, even in Central Europe, is not driven in these heavy congested cities. Even we tend in transport economy to focus very much on these because they're interesting. But not a lot of, how large share of the vehicle kilometers traveled in the European Union, for instance, are in these heavily congested conditions? I didn't find any numbers or even sort of magnitudes of this. So we decided to actually simulate the actual spatial and temporal distribution of the marginal external congestion cost. We left out the other costs, external costs, for a moment, just focusing on the congestion. And we tried to find an area then that would represent like a small country. And then we chose Mälardalen, which is a part of mid-Sweden along round Lake Mälaren, where also Stockholm is. And before you sort of dismiss this region as like this very sparsely populated region in Sweden, it's mostly forest and not so many people. It's actually, if you check Eurostat, you see that this urban area, this 4 million people live in an urban area with a similar degree of urbanization, as the Eurostat call it, as the Netherlands and the UK. It's relatively dense population. It has the same population density as Spain, Portugal, and the US. So it's not that far off, we would argue. And the good thing, and you think about, for instance, the COVID pandemic, it developed in this Mälardalen region very much like it did in the Netherlands and the UK because of its population density. So we believe it's fairly representative for like a country, not a city. We have two big metropolitan areas, which is Stockholm and Uppsala, but also many smaller cities. And the good thing with this region is that we have a transport model that's been evaluated many times. For instance, when we introduced the congestion charges in Stockholm, and it seemed that this model reacted very well. It was able to predict changes on the travel times and traffic flow very well. So we sort of trust it. So it's the best we can do. And then we simulated the optimal congestion tax in this whole region in 4 time periods of the day. AM peak, PM peak, also night, to see how is the congestion externality distributed in time and space in such an area. Next, please. And before I continue doing this, we also scanned the literature and took some of their own studies to say we need to say something about the other external costs. And now we think about, so when we did this experiment, we think about the time like 2040, when most of the traffic is electric. So, okay, it's not electric by then, but sort of approximation. You can think about 2050 as well. And here you see, I'm not going to linger here a lot, but you see for light vehicles, you can't see when I'm pointing here, can you? Yeah, maybe you see for light vehicles, it's actually pretty small cost once you have electric vehicles where you have no emissions externalities from carbon. We think it's in the sense that it's carbon in electricity, we think it's internalized by the EU cap and trade system. So we assume there's no emission external cost from carbon in this traffic. So for heavy trucks, you have a lot of wear and tear, of course, but that's very small for light trucks. For accidents, also seem to be, and we've done a lot of studies, small external cost for light vehicles. And the reason is that light vehicles tend to adapt. So when you have more heavily congested or just more traffic density, it seems like the drivers adapt by taking it more easy. So the accident rate doesn't seem to increase as traffic does for light vehicles. For heavy trucks, it's a different stories. So they have also higher external costs for accidents. So that's basically it. I'm not going to say so much more, but you can see they are very small actually for light electric vehicles, but quite substantial for heavy trucks, even if they are electric. Next slide. So in the scenario then, as I said, we used a national transport forecast model, and we did a scenario for Sweden that the Transport Administration developed. And in this scenario, we have actually 30% more traffic than we have at present, partly because we are richer, but partly also because they predict that the population of this region will increase quite substantially over time. So we have 30% more traffic, so it means that we will have an even more highly congested region than we have at present. And then we try to assess the tolls by running we have one scenario, and then we just change the driving cost a little bit to estimate basically how does the travel time change when you add one more vehicle, so the marginal increase in travel time. And then we just multiply by the value time and also multiply by the number of vehicles, which is D here. So this is a way of assessing the optimal, the external cost of congestion by link in the whole network in the region, by time period and link, as I said. So next slide, please. All right, and in this scenario, we assume the Transport Administration think that the driving cost will be on average 0.8 euros per kilometer, 2040. And then we vary this cost a little bit to be able to compute like how the travel time varies when we change the transport demand, basically, to be able to compute the congestion cost and also the optimal congestion toll, or optimal, you can say optimal kilometer, Pigovian kilometer tax. And as I said, so we assume that we have population growth and higher traffic levels for that reason, but also because the economy is assumed to be growing. I can say that in the European Union, as such, the prediction is that the population will not grow. So this is different for Sweden and the rest of the European Union, when the forecast is that the population will stay roughly constant over time in the future. Thank you. So next slide, please. So this is the results. And these are the pictures, shows this region. The left-hand picture, I think for me and for you, right, is the entire region, and the right one is zoomed into the Stockholm region. And it shows, the red bars shows the increase in travel time when you change the cost a little bit. And then you see it's mostly quite central in Stockholm, but also on the arterials and highways through into Stockholm, and mostly on the highway between Stockholm and Uppsala, which is the other bigger metropolitan area. And when you calculate sort of the median optimal kilometer tax, median per vehicle kilometers traveled, it's 0.4 euro per kilometer. And if you compare this to the present or 2019 kilometer charge translated from the fuel tax, it's actually a little bit lower. But yeah, if you calculate as median for the vehicle kilometers, you're looking at the road stretch. But if you instead calculate the median vehicle kilometer traveled, it's higher. And that's because you have more traffic, you have more vehicle kilometers on more congested roads. So the average tax is a little bit higher, but it's not a lot higher than the present fuel tax per kilometer. And next slide, please. All these numbers, it's difficult. We have done a lot of approximations. We have also done a lot of assumptions about what the world would look like in 2040. And so the exact numbers isn't really what we were after here, but to show the vast distribution. So maybe the most interesting thing is that 90% of the revenue that we collect from this optimal kilometer tax is collected at 10% of the road network. So it's actually very few links. We have lots of congestion. Also, the revenues will be large, but it's quite few links, even in such a big network as we're discussing. So it's not central. It's also rural areas in this region. And 50% of the revenue is collected from 15% of the vehicle kilometers traveled. So that is that distribution is less skewed, and that's because, as I said, you have more vehicle kilometers on more congested roads. So you have a larger share of the revenue collected from larger share of the vehicle kilometers traveled. And if you looked around, you can see that there I have colleagues that did from Stockholm that did in this more sophisticated transport model 2014. They tried to simulate in the Stockholm county only the optimal kilometer tax in a dynamic transport model, which is even better than Sampers that we used. And they basically find the same thing, that they could, by having 70 toll stations, get 96% of the welfare gain of the optimal kilometer tax. So it's essentially the same results, so that you have quite local congestion that you can target pretty well with those links, and the rest of the network has so low congestion that it doesn't really add so much to the welfare to charge them. Thank you. Next slide, please. And I'm not going to say now you need to press because I have made circles here. So I think you need to make some clicks here to show things. Nope. Okay, so this is only distribution. So I'm not going to say so much about this because it's so many numbers, but the key thing here is the huge variation in this optimal kilometer tax. And on the upper half of the thing, you see the distribution for per road length, so per kilometer road, and the lower part of the figure is per vehicle kilometer, which is different because you have more vehicle kilometers and more congested roads. But you see here the median values is pretty low if you look at the road stretch, and it's also pretty low if you look at the vehicle kilometers traveled. So most traffic then will pay lower tax per kilometer than they presently do. But if you look at the 75 percentile and also like the maximum value, the optimal Pigovian tax is massive because you have such high congestion in part of the network. So they will collect huge parts of the revenue. Another interesting thing here, we have been discussing a lot about cities and traffic elsewhere, but the other interesting thing is that most transport traffic, vehicle kilometers, are not traveled in the peaks. So if you look in the first column, if you press, I've made another circle. And the next one, yeah, that's one. Here you see like the share of the vehicle miles traveled in different times of the day. And we see here that the AM peak and the PM peak is only about, 1/4, something like that, of the vehicle kilometers traveled. And the rest of the day, the midday and the nighttime has more than, almost 50% of the traffic, even though it's not in the rush. And that's because it's so many hours. And of course you can say, like in cities like Paris, you have this rush all the time, like night and day. But it's pretty few cities even as Paris. Most spaces in Europe is even less populated or less crowded or congested. Yes, please, next one. So how do we collect this tax, let's say? And I've already sort of touched upon this. So we have the fuel tax, which is very convenient because it's so cheap. You can tax fuel when it gets into the country and high upstreams. You have the vignettes and the car ownership, which is also pretty cheap because it's time-based. You have the roadside equipment. You need like the cameras that we have in Stockholm or DCRC. That's many places in Europe. And here you see the administration costs of them with the cameras that we have in Sweden. It's about 15%. It's lower in Norway, and it seems to be like economies of scale, that the higher revenues that's collected in Norway in more and more cities, the less share of the cost is devoted to the system, but it's still 9%. London is higher. And you can also compare this, for instance, to the parking charges. In Stockholm, it's 18%. That's only to the system of the revenues. So it's quite high compared to fuel taxes, but maybe it's worthwhile, and it seems that it's declining over time. And then you have these, like some kind of GPS-based system that they've tried in Singapore. I've tried to learn what it would cost in Singapore. I haven't ever seen any numbers from that. But basically, and that's what Jonas said as well, it's the enforcement that drives the cost. And it seems what I learned from Singapore and when you discussed this morning is that you need a lot of roadside equipment to make sure that people are not cheating. And that's what drives cost. So please, next, please. So what would be the preferred tax instrument from this? Well, given that you have such a large pair of the revenues collected on so few roads, it seems like some kind of toll system like we have in Stockholm that maybe needs to be larger over time and more links. would be probably the most cost efficient. Now you would capture most of the external cost at fairly cheap price, and given that it's already sort of accepted in Sweden, in the Swedish case, it's probably like clear that that's the way you should do. Of course, it's not perfect, but then you have to be reminded there's always going to be a trade-off here between the cost of the system and how exact you can target the external costs. And for heavy trucks, maybe you can say, well, congestion share is less share of the total external cost because they have higher costs of wear and tear, as Steph said, but also higher external costs from accidents. So maybe it could be, I mean, it wouldn't be so bad just to tax them with the vignette that is time-based, because also the distance varies less than a kilometer tax, the daily distance. Potentially only because it's very cheap, and also because enforcement is much, much better. Next, please. This is like only the Swedish number, but we took the revenues from the system, the optimal tax, and then we compared, and then we did some extrapolation. What would it be for entire Sweden, not only the Stockholm region, by some like rough calculations, and then we find out that the optimal tax would cover the present public cost for the road transport system. So we would probably ensure cost coverage with the optimal tax. But the problem obviously will be that we have huge redistribution effect, because now it's paid over all Sweden, the capital and the densely populated areas and the more sparsely populated areas all pay and all gets from the revenue. But in this new system, when you only tax the congestion and other externalities, the capital, the densely populated area would pay almost everything, not all everything, but like a huge share. And that would distribute it to the rest of Sweden. And we know from the experiment or the introduction of the congestion charges that is very hard to accept for politicians and the population in the cities. So they only agreed to introduce this congestion charge in Sweden if they were able to keep the revenue in the region. So it might be a problem with political and public acceptabilities in these more densely populated areas. Next, please. I'm always in the end. So what brief note on the thing with the fiscal tax, which I haven't touched upon. So as Jonas said, like we have in the transport sector, we often relied on the Ramsey argument that we should tax a commodity that has low price elasticity. But then actually what seemed to have been forgotten is that Atkinson and Stiglitz challenged this already in 1976, saying that if they added to the framework on Ramsey that you have distributional aspects. And what they said that if you take that into account, the optimal rule is probably to have uniform tax on all fiscal consumption good. So it's not particular one on just road transport, but you should have the same. And this result relies basically, I mean, it's just, it relies on that, an income tax. And this is also what Steph Prost has shown in several papers, that income tax is enough to receive or achieve the desired redistribution effect. So consumption doesn't reveal any more information than you already had in income tax. So you can deal with the distribution effect on the income, and then the tax goods equal. And then you also say, like, often is commodities with low price elasticity are often consumed proportionally more by low income people, which is sort of shown. And also all consumption, if you're scared that you get like a revenue loss, all consumption is a much larger tax base. So go for like high VAT or something. It's much more efficient than just taxing road transport in this area. And then you have additional problems like fiscal taxes on commuting will introduce deadweight losses in the labor market. That's a well-known problem. And then the problem that Jonas were talking about as well, horizontal equity, that you want people with the same income that pay the same tax. And effectively, what if you just tax road transport, you will end up taxing families, for instance, more because they drive 40% more than others. rural areas, and you will tax neighbors, maybe different, depending on just how much they drive in their private lives. Also, we know that it's not good to tax road transport, freight transport, because it's just an input goods. Okay, final slide. All right, so from this experiment, we find that the median kilometer tax would be 0.04 kilometer per kilometer, euro per kilometer, which is a little bit lower than the present fuel tax, but it's the mean would be higher. So it's just a larger distribution. We think that like enforcement of the GPS-based systems will drive administration cost, and that you can actually capture a lot of the externalities by only having tolls on maybe 10% of the road networks, which could be achieved by an ANPR city toll. And then the rest of the externalities, which is small for light road traffic, with maybe a time-based tax, because it's cheap. It's not perfect, but it's cheap and it's not that much money. And for heavy transport, maybe the other external costs are not small, but maybe the travel distance doesn't vary so much. So maybe you can go with a distance or time-based charge anyway. But that's, I mean, probably easier with a kilometer tax for heavy transport anyway. It is difficult, and you always have to keep in mind that you need to trade how perfect you target the externality with the administration cost. So you always need to strike a balance there, and you will not get like the perfect system, whatever you do. And it's probably not a good idea to have fiscal taxes on road transport, but much better to tax, just increase the VAT on all goods. That's our conclusion. And now I'm done. Thanks.